Okay, let's go over some word problems of step functions. The first one here says the United States postage rates for first-class mail follow a step function rule. As of January 2017, any letter weighing 1 ounce or less requires 49-cent postage to be delivered. For each additional ounce or portion of an ounce, an additional 21 cents is charged. Graph the step function and make sure to label the axes. All right, so when I write this step function, I want to look for some important information. So the first thing is, how much does it cost for that first ounce, right? If I give a letter and it's between 0 and 1 ounces, it tells me that if I weigh 1 ounce or less, I'm going to require 49 cents of postage in order to mail it. So 49 cents for 1 ounce or less. After that, I'm going to pay an additional 21 cents per ounce or portion of an ounce. So that means that as soon as I go over 1, if I'm 1.01 ounces, I have to pay that additional cost. So as I write a step function here, I'm going to consider these two things. So the very first amount that you would have to pay, the lowest amount you could pay is 49 cents. So I'm going to start there with 0.49. And that is only if my letter is between 0 and 1 ounces. So I'm going to say 0 is less than x is less than or equal to 1. I'm not sure if a letter could really weigh 0 ounces. Maybe it could be equal to 0, but let's just stick with it's not equal to 0. You're mailing a letter and it weighs something. All right, after this, as soon as you go above 1 ounce, you're paying an additional 21 cents. So to find the next step of this function, I'm going to add 0.49 plus 0.21. So the next step is 0.7 cents. And that is for anything that is greater than 1, so 1 is less than x, up to equaling 2 ounces. Okay, it's only for the next additional ounce. So that's only up to 2 ounces. As soon as I go over 2, again, I have to add an additional 21 cents. So 0.7 plus 0.21 is 0.91. And that is if I'm between 2 ounces up to being equal to 3 ounces. All right, again, going up another step, as soon as I'm larger than 3 ounces, I weigh more than 3 ounces, I'm adding another 21 cents. And so that brings our cost up to $1.12. And that is for ounces greater than 3, but less than or equal to 4. Now I noticed this graph that we're given goes up to x is 5. So that's where we're going to go up to with our step function as well. So we're going to go one more up to 5 ounces. The next step of this function, again, I would add 21 cents, and we've got $1.33 between 4 and up to equaling 5 ounces. So here's our step function for how much you would pay in postage for various weights of letters. Now let's graph it. So I'm going to start with the 0.49, starting with the point where x is 0. So we're going to 0.49. If you need help, remember we're essentially plotting this point, and it is open because it's just less than, not less than or equal to. So I'm going to go on my graph. Before we do that, let's label our axes because right now we don't have x and y labeled. So the x-axis, we are saying that x represents the weight in ounces of the letter. So we're going to go ahead here and label for letter weight in ounces. And then the y is how much we have to pay in postage. Okay, now we're ready to start graphing. All right, so I'm going to start with the point 0.49 with an open circle. And I'm going to get zoomed in here so I can do the best I can to get 0.49. Again, on your paper, it is pretty small, so just do your best at roughly sketching where it should be. And that is from 0 up to 1 for x. So I'm going up to 1.49 to draw the first step. All right, so that's the first one. The second one is y equals 0.7 from 1 to 2. And again, 1 is open, 2 is closed. So I'm going to go at 1.7. So x is 1, y is 0.7, open circle. And 2, x is 2, y is 0.7 is closed. And draw my second step. The next one, again, 2 is going to be open, 3 is going to be closed. So we're starting at x is 2, y is 0.91 with an open circle. And then we're going to x is 3, y is 0.91 with a closed circle. There's our next step. All right, the next one is y is 1.12 from 3 to 4, where 3 is open and 4 is closed. So I'm going to go to x is 3, y is 1.12. Let's see, that would be about here. And then 4, 1.12 is closed. Draw my step. And the last one, we've got y equals 1.33. 4 is open, 5 is closed. So I'm going to plot that. 4, and then go up to 1.33. And then 5, 1.33 is closed. There's our last step. All right, so as you can see, our step function here goes up. Uh-oh, I did that last one a little bit too high. I thought that looked funny. So this step function is an example where all of our steps should be equal increments apart because every time we only added 0.21. So I noticed that that last piece was up too high. That's a great way to check your work to make sure that you are correctly plotting your points. Should be right here. There we go. That is better. All right. Now, there's a follow-up question. It says, based on the above information, how much postage is needed for a letter weighing 4.25 ounces? Again, this is just like what we did with piecewise, where we were evaluating f of a number. I just want to know when x is 4.25. So I'm evaluating f of 4.25. Where would 4.25 fit in this long list of inequalities? Well, 4.25 is greater than 4, but less than 5. So that would be the last row here. The answer is you would pay $1.33 for a letter weighing 4.25 ounces. Let's do another step function application problem. This one says your favorite dog groomer charges according to your dog's weight. If your dog is 15 pounds or under, the groomer charges $35. If your dog weighs more than 15 pounds, all the way up to 40, she charges $40. If your dog weighs more than 40 pounds, all the way up to 70 pounds, she charges $50. If your dog weighs over 70, she charges $60. Graph the step function and make sure to label your axes. So in this example, we are given information about each step individually. Notice it doesn't say that at each step you go up by a certain amount. So unlike the first problem where our steps were all evenly spaced, this one that might not be the case. So we're going to start by looking in our problem to find all the key pieces of information. The first key piece of information is for a dog that is 15 pounds or under. If your dog is 15 pounds or under, you will be charged $35. Well, that's going to be the first step in our step function then. So for a dog 15 pounds or under, I get charged $35. So it's going to be y equals 35 if 0, because we can't have a negative weighing dog, so 0 is less than x, is less than or equal to 15. And the reason it's less than or equal to is because it is if my dog is 15 pounds or less. So that means my dog could equal 15 pounds and I'll still only pay $35. All right, the next step in this function is that if your dog weighs more than 15 pounds up to 40, then you'll be charged $40. All right, so that's the next step. You're going to be charged $40, so Y is 40, for a dog that is greater than 15 pounds, all the way up to being equal to 40 pounds. So there's our inequality from 15 less than X less than or equal to 40. All right, let's see what's next. If your dog weighs more than 40, all the way up to 70, she charges you $50. All right, so Y is 50. That's how much we're being charged. And our inequality starts at 40 pounds, so 40. But remember, we're strictly greater than 40. So it's, as soon as you're over 40 pounds, so 40 is less than X, is less than or equal to 70, because your dog can equal 70 pounds here. And then the last bit for those super heavy dogs, let's see. If your dog weighs over 70 pounds, she will charge you $60. So $60 for a dog that is, so X is greater than 70, because it's all dogs greater than 70 pounds. So here's our step function. Let's start to graph this first by labeling the axes. So our X value, all our inequalities were written in terms of the pounds of your dog. So let's label our X-axis as such. Weight of dog. And it was in pounds, so I'll do LBS. Then the Y values all represented the cost of getting your dog groomed. So we're going to label our Y-axis as cost. Notice this one also isn't labeled with intervals as well. So let's think of what intervals would make sense. We want to go from 0 all the way up to 70 on the X-axis. So maybe if we go by fives, let's see. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. Perfect. That'll be good for us. So I'm going to label my axes going up by fives. Maybe I'll start skipping now that we know. 40, 50, 60, and 70. And then our cost goes from 35 to 60. So again, it might be useful to count by fives as well. So 5, 10, 15, 20. And I'm just going to skip the fives place just to save room so it doesn't get too messy. All right, so let's go ahead and graph our step function here. I'm going to start with the first one. The cost is 35 for a dog that weighs 0 to 15 pounds. 0 should be an open point because it is strictly less than, open, and 15 will be closed because you can equal 15 pounds. Now, my Y value is 35, so I'm going to go to 0, 35 on the graph. 0, 35 is right here. It's an open circle. And then 1535 is a closed circle. Draw the line. There's our first step. The next step is Y is 40 between 15 and 40 for the X's. 15 should be open and 40 will be closed. So I'm going to go to 15 on the X, 40 on the Y, open circle. And then 40 on the X, 40 on the Y, closed circle. The next one is the $50 cost for a dog weighing between 40 and 70 pounds. Again, you can't equal 40, so it's open, but you can equal 70 pounds here, so it is closed. So I'm going to go to 40 on the X, 50 on the Y, open circle. And then I'm going to go to 70 on the X, 50 on the Y, close circle. Draw my line. And the very last piece here, $60 for all dogs greater than 70. And now I know that realistically your dog could not weigh infinity pounds, but because there is no upper bound, there is no maximum, we are going to draw this with an arrow on the one end, okay? So we're going to go to 70 as an open circle because your dog needs to be greater than 70 here. So I'm going to go to 70 on the X, 60 on the Y, open circle, and then we're going to draw to the right for all X's greater than 70, and it will continue on forever. So now the follow-up question says, based on the information above information, how much would you pay for a dog weighing 40 pounds? Start here. 40 pounds, where would I fall in this inequality or these different inequalities? Which one would 40 fall into? Is 40 between 0 and 15? No. I notice there's a 40 here and a 40 there, but only in one of them can I actually equal 40. And that's right here because it says X is less than or equal to 40. So 40 would fall in the second row, which tells me that it would cost me $40 for a 40-pound dog. Now, what if my dog is 15.8 pounds? Where would that lie? Well, I've got 15 right here, but is 15.8 between 0 and 15? No. 15.8 is greater than 15, so that's going to bump me up a line. I'm going to have to pay more, even though my dog's only a little bit over 15. You would pay $40 for this dog as well.